I'm Eric. I am with a company called ESI, and I'm going to talk to you a little bit today about how our industrial customers, our manufacturing and product design customers, are using our solution, IC.IDO, to use VR to help bridge part of the gap that's been created in the digitalization of our design processes, right? So one of the things that I would contend is that when you think about the evolution of mankind and how design used to work, is that, in the very primitive days, we just built things, right? Everything that we made was in fact a prototype, right? The first thing we made was in fact a prototype. We want to make a tool, you start banging rocks together, sharpening them up, that prototype becomes your actual axe. You use that one until that one breaks, and you chisel away and make a new one, right? Now, as industrial revolutions happen, and as we start engineering, designing things, then start these formalized engineering design processes, right? Where maybe back in the day, and maybe not even that long ago, let's just go back 20, 25 years ago, where somebody was designing, maybe in the early days of CAD or back on the vertical board, drawing a new product, that every time we built something new, that new thing that we would build, we draw a picture of it, and there's a metal model maker or there's a model maker standing there looking at the drawings, and they would go and realize those product designs, those drawings, as a physical object, right? And as they made that physical object, sometimes they'd come back to you and look at your drawing and say, I was trying to build that prototype based on your drawing, and I can't even put the thing together. Like these three pieces, these three bits and baubles that you have going together, they don't fit together. See? And they would show them that when you take these two different components and you try to bolt them together to make a subassembly, that they couldn't fit. So the idea that I'm proposing is that now we can use kind of VR as this next stage of evolution, going from that physical, practical design to digital design, and try to fix some of those gaps that got created when you think about how digital design has left some questions sometimes unasked. It's not that these questions are unanswered. Sometimes the questions are not even asked about how these things get built and how these things get put together. So when you think about the typical design process, right? The typical design process, that slide didn't build properly. Normally you think of design process as this linear flow. Someone starts off with a new product concept, that goes to product engineering. From product engineering comes the method planning or the process engineering. From process engineering, we develop tools, we build the tools, we do some prototyping, we do some piloting, we go to production, and then there's sales and after sales. Right? That's very much the linear flow of the way things used to be done. But now when you think about how the world has evolved, right? Now you can see the way we've compressed the whole design cycle. There's all this idea of simultaneous and synchronous engineering, and notice that the prototyping and piloting went away. It's been a long promise of events and shows and speakers like me at events and shows like this, that we're going to do away with the physical prototype. No more physical prototypes. That's what everybody in CAD and CAE and FEA will tell you. No more practical prototypes. But my contention is that maybe there are things that we're not finding out because we don't build those physical things anymore, right? If you think about how what we might want to do and what we might need to accomplish because we don't have those physical prototypes, is we have to find a way to virtualize this building of the component. We sometimes need to virtualize the integration of how all these things that are designed in final product position, as if they magically teleport themselves to final part position. How do we make sure those things can actually be built by human beings or possibly by robots in the future factory? And also, very importantly, for many of our customers, how can we use virtual technology to validate that someone can actually service or maintain these things that we just finished building and designing? So that's our objective when we talk about it. Now, some other things that you might consider for the product development journey, right? Some people today have already been talking to you about different applications and solutions they have for virtualizing and using VR to help resolve the design and styling issues, right? So overlapping with that concept, you can see that I've made that little caret down below for digital virtual clays, right? That is one possible use case for virtual reality. There's other popular use cases down at the end of that product chain for things like, how do we train our operators how to build and assemble the cars of the future? How do we introduce our products of the future to the consumer, to the purchaser, right? Those are all very interesting, very novel uses of VR, and actually those are the ones that get the most amount of attention in my experience. What we're gonna focus on is that meet in the middle, between the point when people decide if the thing's pretty enough and how we're going to sell the thing, and that stuff in the middle where we want to use VR to help people use technology to integrate the product designs and make sure they can design them well for manufacture, for service, and all the interesting stuff in the middle, product engineering, process engineering, and tooling development. So what we propose with IC.IDO is to create for you a virtual reality tool for engineering that allows you to have this immersive and interactive platform where you can do collaboration in the engineering process and in the engineering time scale. Right? Some of the things that people talked about, the challenges in bringing VR or using VR for design, was this whole idea of how do I convert my data into VR assets? That's one of the things that we really focus on, making transparent to the user. They want to take CAD data, and I need to see that in VR more or less immediately. I also want to be able to interact with it. I should be able to touch it. I should be able to experience it. I should be able to move it. And when I talk about interaction, something more interesting than making things transparent or translucent or cutting sections interactively, but I actually want to pick up the component and carry the component from the storage container to where I actually build it onto the car. And of course, this has to be collaborative. Right? A lot of our decisions that we make today are in fact highly collaborative, and we're working with people who are not co-located with us. Now, very traditionally in this illustration, this picture, you can see we're standing in front of the very classical power wall, right? We have 3 engineers standing in front of the power wall, and they're discussing the installation of that engine component into that engine compartment of that Audi, right? And that was the first socialized, virtualized, collaborative VR space, was standing in front of a power wall or a cave. But nowadays, people have said, well, we're going to go to HMDs. We want to make things more collaborative. We want to make things interactive, more achievable. So one of the very simple things you can try to do with VR, this is just a 2-dimensional screenshot, of course, of our workstation. But this is using VR and IC.IDO to solve a very integral packaging concern. Let's call this dynamic packaging, as opposed to typical static packaging. Normally, when you're designing something like this steering mechanism, this shock-absorbing system for this car, you would design it with this idea that there's an envelope, a max envelope and a min envelope of where all your components should live. What we have is we have teams of engineers who are using our application today to solve this exact problem. When I design this steering system for this car, and I connect all the hoses and the wires that connect to that steering mechanism, when it travels through the full range of motion, are those hoses going to pinch, or are they going to bind at any place in that flow? So teams of engineers at one of our German OEM customers, I won't name names, but they're down there in the Stuttgart region, right? Those guys import their data into IC.IDO, and they define very basically the physics of that device. Where the hinge is, how does that shock absorber slide on its axis, and of course they highlight a bunch of those wires and cables and make them one-dimensional elastic bodies. And then they just animate that by grabbing onto it at their desktop, sometimes just using a space mouse, to animate that thing going up and down and turning through its range of motion. They tell me they can solve about 70% of their problems just doing desktop work. Every once in a while, they need to see this immersively in VR, so they can stand up, put on their HMD, and with the HMD, or walk over to their power wall or cave, and they can experience their designs in immersive VR and see if there are, in fact, any design concerns with the packaging or integration of that product. This is a video that honestly, this is not the best video I've ever shot. This is the video I just shot this weekend, or this past week. This was my first attempt at real-time, what do you call this, rotoscoping, or the idea of doing the green screen, right? So in this green screen animation, what I have is this, I actually used our collaborative platform to record, let's see if I can play that video one more time. right? This was what, using my collaborative platform, I was using the camera on the Vive to record what my colleague was doing in front of a green screen, and then I was overlaying that on top of what he was doing inside of the virtual reality space. And in this case, we're doing a packaging analysis and installation analysis for that windshield washer bottle that's got to go in through the wheel arch. Now, this was a very interesting story on this particular car. Most of the time, they would just validate this by looking at static space claim images taken from the CAD, and they would have approved it, right? Everything looked great. This is a Daimler C-Class, and they said, yep, it's going to look great. We're going to be able to build these cars. They even could go to the prototyping and build a full mock-up, and it would have been fine. Except for one thing. They did not do all the variants initially for the speed Autobahn package. Right? The Autobahn speed package has those big, fat, ventilated discs on it. It's got a bigger, larger braking system, right? And when they tried to install that washer bottle with the bigger braking system, it couldn't make its way into the wheel arch. They actually emerged in VR a situation where they could not build their AMG trim package with the high-speed discs on it with the same washer bottle. And they would have had to face a design consideration. Should we design a special washer bottle just for the small lot of high-performance vehicles? Or should we rearrange the assembly plant in order to put that thing in before the brake calipers and the brake discs get installed, right? Or do we just make this an aftermarket installation, that people put the washer bottle in at the dealer site, right? None of those are very attractive. And by using VR, in place of their normal prototype piloting assembly builds, they were able to emerge that this would be a problem for that small subset of vehicle variants. And that way they could redesign the washer bottle. That washer bottle has a kind of a cutout shape in the back of it now. And that cutout now allows it to easily install around that larger brake caliper and a larger brake disc. Other things where we use VR for virtual integration is to actually validate things like operator requirements. For this, in fact, is a pharmaceutical bottling line that is being made by a company called Bausch & Strobel. Bausch & Strobel is a provider of these manufacturing lines for custom-based pharmaceuticals. On the very top image you can see there, this is how their piloting process would go whenever they're making a new line for one of their customers. They would build wood and plexiglass models, and people would stand in front of them, put their hands through those little sanitary gloves, and see if they could reach all the stuff they're supposed to reach. That was the peak of technology about 3 years ago for them, right? They've been using VR now to use virtual reality and build a power wall, and in this case you can see on that picture on the lower right, now they're standing in front of a power wall with active stereo. They're reaching their hands through those same kind of rubber gloves and same kind of plexiglass wall, but now they're getting this kind of mixed reality, dual reality of what would I actually be able to reach inside of that assembly cell, right? So this has really allowed them to build a kind of digital twin of their assembly line long before those carpenters would have normally been able to build that prototype up. Right? So they've traded some virtual reality engineering for practical construction of prototypes. Other things that you'd be interested in using VR for is proving out other human factors for assembly, production, or service. In this case, we were just looking at what happens when I put that ratchet wrench on the necessary bolt to tighten down. In this case, I think that's the bolt to tighten down like the water pump or something like that. And they just wanted to see, where's it going to collide and how many rotations, how many actual clicks on the ratchet can I actually get before I bump into that hose on the top and the hose below, right? And this was done, in this case, this is a desktop capture that they were solving this problem on the desktop, but I could also do this in VR to make sure, can I get the hand tool in? Can I get my hand around that tool, or am I going to beat my knuckles up? This animation, or this video right here, this is a VR rendition or VR version of me doing that very same thing. That is me in the lower corner. That is a hammer that I have bolted on, right? I just zip tied on the HTC external tracker. But in my mind, when I was in VR, it was that hand tool. It was that air tool that I might be using to tighten down something inside of that Volkswagen Passat. So in this case, I'm doing real-time interactive VR, where I'm reaching in with a weighted tool in my hand, but I can see real-time collision, real-time collision handling, and impact detection of that tool reaching into that car to make sure that this would in fact be assemblable or serviceable. How many of you guys have seen this picture before? Right? This is at GTC, right? Silicon Valley last year. Jensen gets on stage and he's talking about Project Holodeck, right? And everybody's been so excited about Project Holodeck. You go to any NVIDIA display these days and they're gonna have a bunch of demos doing Project Holodeck. And everybody asks them, when will we be able to actually do this? And my answer is, well, we could do that today, right? We've been doing collaborative VR since 2008, mostly on power walls and caves, but now, with the availability of the HTC Vive and the Oculus Rift, we can do collaborative VR inside an HMD. So in this picture, this animation, right, you can see here, that's me in the lower corner in the HMD, and I'm the one that's moving that tire around. My colleagues are in a conference room and standing in front of a power wall, and they're watching active stereo display of me doing that same assembly operation, right? So we could take turns and we could collaborate of who's doing what and how does that look to you. Or they might stand in a different point of view from me and they might see something that I can't see from my operator's point of view. So we've been using virtual reality to help us do production cell planning, production cell or assembly ergonomics, visibility studies, and things like that. Right, that picture that you can see right here, there's two pictures where one person wearing an HMD, again, another person standing in front of a power wall, but it's the same installation procedure. They're flying a hybrid battery into the back of a Daimler C-Class hybrid, right? And the very first time I ever did this demo is standing behind there with my hands on that load mechanism trying to load it. And someone's like, yeah, Eric, just fly the battery in. It turns out I can't fly that battery in because I'm too short to be able to see over the top of that battery in order to see am I clearing the bumper or not. Now the guys at Daimler are like, oh, nobody in our plant in Sindelfingen has any problems flying that battery in. Why? Because they're all a little bit taller than Eric. And it turns out that if you want to work at that assembly cell, if they didn't find out what we found out in VR, they'd have to have a little cardboard cutout of Goofy standing at the, the side of that line saying you have to be at least this tall to build this car, right? That's the kind of thing that our customers are using VR in order to avoid. Here's another example of now using VR a little bit differently. Most of the stuff I've shown you so far is VR, where I'm doing first-person ergonomics or first-person human factor study, right? I'm in VR trying to reach something, trying to access something, and I either see it or I don't see it, I reach it or I don't reach it. Those are VR studies that are done and accessibility studies that I finish like in a minute, right? In 1 minute, I can find out whether or not I can reach it. But of course, I probably still have to do a report for somebody else. So now in these videos, you can see that I'm taking the same things that I might have done from a first-person point of view, and now I'm doing third-person analytics, where I insert a digital human into the model. And what we're able to do in VR is I can take certain animated sequences, these sequences of perhaps I loaded that tire into the back of the car. I can record that physical behavior in VR of that tire going in the back of the car, and now I can take the 95th percentile German male and reinsert him into that view and have that playback of him handling that tire and putting that into the back of the car. And then I can do that again with the 5th percentile female from Southeast Asia and see how they'd be able to load that into the car. Right? So the things that I experience in VR, I can now capture and record and play back those physical interactions with a third-person analytic. So how we see virtual reality really applying the most value to engineering is informing engineering decisions. And for me, I always talk about these 3 Ps: product, process, and people. And when I want to use VR to help me prove out engineering decisions, I'm usually doing them to inform a new product decision or a new process decision or how people do that work, right? And if I had a long and cumbersome process in order to take my CAD data and turn that CAD data into VR because, I have to ask my Unity developers to develop a new game level, right? Go into game level generator and build a new level generator of this new robotic load arm to put that battery in. If I had to do that every time we changed that arm design or the vehicle design, this would not allow me to iterate quickly. So we really want to be able to help people iterate at the time of the design because the design data, and most of those videos that I've shown you, those might have been used once or twice to drive an engineering decision, and we threw that engineering experience away, except for Eric to make pretty videos from them. But for the most part, those VR experiences, we don't even call that authoring. People always talk about VR authoring experience, making content. We make the content, we use it once or twice. We make a decision, we throw it away, we get new data. And you should be able to do that fluidly at the speed of the decisions you have to make. And that should work the same way whether I'm doing desktop level exploration engineering studies, whether I'm doing interactive, collaborative validation, or if I'm doing power wall reviews or cave reviews. I need to be able to use the exact same experiences, the exact same software across all those platforms. So the next level of evolution you might want to talk about is now how do we do VR without the cable? So the last thing I can introduce you to is something that I was really hoping would be launched this week, but we had to fix a couple driver issues with NVIDIA and Microsoft Cloud Services. But what you can see right here, that is an illustration that is me holding my phone, and that is VR data, real CAD data, so that's PTC Creo design data, turned into VR. That's a Volkswagen Passat engine, and I'm streaming an omnidirectional stereo view to my mobile phone. And that's something that we're going to be launching probably early April so that people can use the cloud to drag their CAD data from a file explorer into a CAD browser and immediately turn that into immersive, streamable data that anybody that has one of these in a Google Cardboard in their pocket would be able to experience VR. Thank you.